This is part 3 of section 5.4. We want to verify each of these identities. So sine 2x plus sine 4x over cosine 2x plus cosine of 4x is equal to tangent of 3x. So what I'm going to do is I'm going to start off with my left-hand side and use my sum to product formulas here. So I have a sine plus sine. Okay, so I have 2 sine of, I add them together and divide by 2, so that's going to be 6x over 2 times cosine of them subtracted. 2x minus 4x will be negative 2x over 2. Okay. Over, now cosine's added, so 2 cosine of x plus y over 2, so that's going to be 6x over 2 times cosine of them subtracted, so negative 2x over 2. Well, the 2's reduce. That reduces, those are the same. So I have sine of 3x over cosine of 3x. And then one of our quotient identities says that this is the same thing as tangent of 3x, which is our right-hand side. So this is simplified, and it is verified. Okay. Now let's do the same thing here with cosine of 12x minus cosine of 4x over sine 4x minus sine of 12x. And we want that to equal tangent of 8x. So here I have cosines subtracted. So I'm going to use this. My left-hand side is equal to negative 2 times sine of 12x plus 4x would be 16x over 2 times sine of 12x minus 4x, which is 8x over 2. This is over. Now do the same thing here with sines subtracted. So that is 2 sine of x minus y. Make sure you're using the correct order here. So 4 minus 12 is negative 8x over 2 times cosine of 4x plus 12x, which is 16x over 2. Okay, so I have negative 2 sine of 8x sine of 4x over 2 times sine of negative 4x cosine of 8x. Now remember that sine is an odd function, so if I have a negative here, I can move it out. So in the denominator here, this is the same thing as negative 2 sine of 4x cosine of 8x. The negatives 2's cancel, sine 4x cancels. So we have sine of 8x over cosine of 8x, which is the same thing as tangent of 8x, which is the right-hand side. So this identity is verified. Okay, so now let's do this one. I have sine 2x plus sine 2y divided by sine 2x minus sine 2y. And I want to show that that is the same thing as tangent of x plus y over tangent of x minus y. There are probably a couple different ways to get this done. I'm going to start off over here and hope to end up over here. So let's take this left-hand side and use our sign, addition, and subtraction properties. So in the top, I have 2 sine of, that's going to be 2x plus 2y over 2. Now, remember that the reason I'm doing that here and not up here is here, these both had x's in it, so I could combine like terms. Here I can't, so don't let that part mess you up. It's just the fact that we have an x and a y here, and that makes that a little bit more complicated looking. Times cosine of x minus y. So cosine of 2x minus 2y over 2. And this will be over 2 sine of x minus y, so 2x minus 2y divided by 2, cosine of 2x plus 2y divided by 2. Okay, well, you can see here that these 2's are going to cancel out. And then for each of these, you can factor a 2 out and then reduce it. Or you can think of it as putting it as 2x over 2 plus 2y over 2 and then reducing it. Either way, we get sine of x plus y, cosine of x minus y, over sine of x minus y, cosine of x plus y. And that's simply reducing each of these arguments for each trig function. Now what we have here is I have a sine x plus y cosine over cosine x plus y. So if I take these two, that is the same thing as tangent of x plus y, because I have sine over cosine. Here I have cosine over sine of x minus y. So that is cotangent of x minus y. I'm almost here. I have the tangent of x plus y. I have cotangent of x minus y. Well, we know that this is the same thing as this. Which gives us the right-hand side. So I have tangent of x plus y over tangent of x minus y.